Hello guys, welcome to my new video. So the topic of this video is that we will be going through a multi-class classifier model problem here, and we'll be trying to make the model with the help of Facebook's PyTorch. Like, this was a demand which I was getting a lot from the commenters, that please make a video on PyTorch or how to use PyTorch. So what we are going to do in this video is that we have a data set here. I'll show you the data set. So it's a car data set which has basically two folders, that is training, validation, and in all those of them there are three categories. So it has front, rear, back, and if you see inside, it has basically images of data. So this on this data set we are going to make a multi-class classifier with the help of PyTorch. But not just that, we are also going to use transfer learning over the classifier so that we get better accuracy. So transfer learning, if you are not aware about transfer learning, state-of-the-art models are present inside TensorFlow, Keras, PyTorch, and you can load them over the top of your neural networks to get better results. So without wasting more time, let's get started. So I'll walk you through the code, and in the meantime, you'll be getting an idea how to run it. You'll understand what is the logic behind it. So first of all, I'll be mounting the drive here. So before that, let me connect it to GPU. And here I have the Pro Collab Pro version here. So we are using V100 GPU and we'll be storing it. We'll connect it. Right, the drive is now mounted. Now we are importing some dependencies. So we are importing the torch, then from torch neural network, from torch optimizer, the different type of optimizers. From torch vision, we are importing some datasets, model transformations, etc. And from the utility class of torch, we are importing the data loader. So this is going to be required for this code. So let's import it first of all. Then we are setting up the device to CUDA, like since we wanted to run on GPU, or if CUDA is not present, we can pass it to CPU. So here we are setting the device. Now we are defining the data transformation for the training and validation folder. So what data transformation here means that we are augmenting the data set into different type of images more, so that we are able to get more data with a smaller number of data set also. So the transformations that are defined here are random resize, then horizontal flip, and besides that we are just normalizing it and converting the transformations to tensor. Same with the validation set, and PyTorch has this ability to do it in a single go, just like Keras has the image gen. So let's run it. That's it. Then you can just pass the data directory here directly. So let me pass it. Then we have these functions which are imported from the above. So data loader was imported here, and that will set up this entire augmentation on the training and validation part. So let's run it. So pretty quick, right? Now the next part is to load the pre-trained model. So the pre-trained model that we are going to use here is ResNet 18. So besides the ResNet 18, there are many other models available which you can use for this type of CNN problem, like VGG16, VGG19, DenseNet 201, etc., etc., NASNet. There are a lot of models. You can just research about them over the internet, and also their support is present in PyTorch or not. So just load it, pre-trained equal to true, then we store it in this variable, then we extract the features from it, and this model features will be helping, like we'll be passing each and every image to this feature extractor, and that features we'll be using for our model training. So let's load the resident model here, and it's a 44 MB model, pretty quick it was. All right, so now we are defining that the last layer of the model that we have defined should have three fully connected layer, because we are assuming that there are three classes here, right? There are three classes in the folder that I showed: front, rear, and side. So this is side, by the way. All right. So therefore we are passing the last dense layer as 3. Then we pass the model to device. And since this is a multi-class classification problem, we define the criterion, that is the cross entropy, as categorical cross entropy, and the optimizer that we are selecting here is stochastic gradient descent, that you can just specify from the optim util object that we had called above. The learning rate is defined as 0.01. Momentum is 9. So just run this part. Now here is the actual training part. So I'm going to run this model over 25 epochs and see how is the result. So we have defined the like for list which will capture the training loss, training accuracy, validation loss, and validation accuracy, because we will be plotting it once the training is complete to see how the model is performing. So here we start with the training. So we have defined four empty lists which will capture the training loss, training accuracy, validation loss, validation accuracy, because that will be defining how the model has performed. So we will be running the model on 25 epochs over the training and validation, and this is the code for the same. All right, so let's run this piece of code and let's see how it goes. Okay, TQDM is not defined because of the spelling error here. All right. Okay, so the training has started. It shows that okay, 25 epoxide needs to run. So let's wait up till this training is complete. All right, the 25 epoch training has been completed. All the data has been stored in the specified list. Now we can plot it with the help of matplotlib and see how it has done. So lint is not defined. Let me just import that. All right, so let us rerun it. I had not imported matplotlib, and yeah, so now the importing is done. So you can see with the number of passing epochs, the loss is decreasing. This is a very good thing when you are training a model. If the loss is decreasing across both validation and the training data, so that's a good thing. And you see that as the epochs are increasing, the accuracy is also increasing. This is also a very good point. So at the end of 25 epochs, you can see that the training accuracy has reached up to 85 percentage or almost greater than that, and there is also not much difference between the training and the validation accuracy. So that's a very good thing. And like if this difference is still lesser, that's more of a perfect fit kind of model. And once you have this kind of model, you can definitely use it in production. So after the model has been trained, you can save the model in the form of a dictionary, and you just need to take care that the name of the model is from the .pth, because this is a PyTorch model, right? So torch.save. So this will, what it will do is that it will save it in your drive. Then you can retest the model whenever you want to. So this is how the model will look like if you just paste model.evolve. It will give you the basic idea of all the layers that are there in your model, and whatever convolution layer, whatever batch normalization layer, whatever uh, dense connected, fully connected layer are mentioned, that will be given with the help of this eval method. Now what we'll do is that we'll try to retest the model on some images that we have. So we have defined again the three classes because the classification is from this three class only. Front, rear, and side. We pass a new image. We open it with the help of this Pillow, is a library which can help you to work with CV, computer vision, and then you unsqueeze it, pass it to the device, and make it in the form of a tensor. Once you have the tensor, you can pass, like you can then pass it to the model. Once you have that, you are good to go. So let's just get the prediction for the same. You can also display it and show it this way. All right, so this image is belonging to the class front, and that is actually correct, right? This damage is in the front part, so that's correct. Now we can also test it on some more images. Let's see how it does with that. Okay, so it shows that the damage is in the rear part, and this image is classified as a rare image. Let's check this one. All right, so this is a side image and it's doing good on that. So this is from the validation set. You can also pass any other unseen data to the model and get the predictions as you require. So this is how you can run, you can make a PyTorch based multi-class classifier model. Very easy to make, very easy. The code is very easy to understand, and transfer learning is very simple to do in PyTorch. And in the next video, we'll be running the same model with the help of TensorFlow. And in the forthcoming video, we'll try to do a comparison, that is a time comparison between PyTorch and TensorFlow over the same model to see which is more quicker. I hope this video has added some knowledge to your machine learning journey. If you like my work, please do hit the like, share, and subscribe button.